argon.
Oxygen is a mixture.
No, pure oxygen is a pure substance.
But that's what we're breathing.
That is what we're breathing, but 78% of air is nitrogen. Only 21% is oxygen. And the rest is just trace things.
So what about if you're breathing from like an oxygen tank?
Well, if you're breathing from an oxygen tank, you have a tank of probably just oxygen, although they usually use compressed air, so you still have a mixture there. If you're getting an oxygen treatment at a hospital or something, that's pure oxygen. That's different. How about sugar? Pure substance or mixture? Pure substance, because it's just sucrose. Table sugar would be. How about trail mix? That's a mixture, right? You have nuts, raisins, candy, sunflower seeds. Okay. How about gold? Pure substance, because it's just one element. Okay. Going on to number 12. Define heterogeneous and homogeneous mixtures. So in number 12, you're going to need to be able to give me an example of a heterogeneous or a homogeneous mixture. Trail mix was a great example of what? A heterogeneous mixture. How about stainless steel? That's a homogeneous mixture. How about platinum? Homogeneous what? No. Platinum is an element. It is a pure substance. You will have those kinds of answer choices in there. Okay? The answer choices are not going to be only mixtures. So if you know you're looking for something that's mixture, and the question is the difference between which one's homogeneous and which one's heterogeneous, then you can weed out the answer choices that are the elements and the compounds, because those are pure substances. Okay? They all tie together. But heterogeneous and homogeneous mixtures, their appearance is very different. Homogeneous looks the same all the way throughout. And a heterogeneous, you can see the different parts. So I had that solution of copper sulfate, which is just a blue solid dissolved in water. Copper sulfate, so that's copper sulfate and water. That's a homogeneous mixture. We can't tell where the copper sulfate pieces are and the water pieces are. And then I had that mixture of metal shot where we could see the different shapes and sizes of the aluminum and the lead and the copper. That would be heterogeneous, because they're going to, you can see the bubbles and they're going to separate. Okay. Alrighty, 15. Define or describe the process of distillation. Distillation is one of our common methods of separation for what kinds of substances? Pure substances or mixtures? Mixtures of what? Liquids. Mixtures of liquids. Where are you finding that, Chantal? In your notes on what part? In B, separating mixtures. So we have examples of that right in our notes. Again, it all ties together here in chemistry class. So if we wanted to take a sample of tap water and purify it to get rid of the minerals, and we want just the water part, we could distill it. We could also run it through a filter, or like a resin chromatography type filter. We could boil it, distill it and boil away the water, and we'd have the residue left over. Let's see, 16. Compare a compound and a mixture, the similarities and differences. This question says, what is one difference between a mixture and a compound? A compound is a pure substance, and well, then what is a mixture? If a mixture isn't a pure substance, then what's in it? Two or more pure substances. They could be elements, they could be three compounds, they could be an element of a compound, or some elements and some compounds. Pure substances, we describe them, they're all in one phase. They're all the same phase. And mixtures, heterogeneous mixtures, are in different phases. Okay? I would suggest you go back and look at the definition of the term phase, because you're going to see that in a couple different questions.
Did we skip 13?
No, because I saw that and I just went back and did it. I think we did skip 13, but I noticed that on my paper, which is why I'm emphasizing that you need to understand something about the word phase. Okay?
Yeah.
Okay. In a tossed salad, we have lettuce, tomatoes, onions, carrots, cucumbers, croutons, whatever. Those are all different phases. There's a boundary between one substance and the next. Okay? The skin of the tomato is a boundary. In a glass of iced tea with ice cubes and a lemon wedge in it, we have the tea phase, we have the ice cube phase, and we have the lemon wedge phase. We can see there's boundaries between those. But the iced tea itself, being a homogeneous mixture, is all in one phase. It's all liquid. We can't tell where the tea molecules are and the water molecules are, even though we know they're both in there because of the colors and taste. All right, 17, write a chemical symbol of an element. Well, this is going to be incredibly easy. How do we write symbols now? Not those the alchemist symbols that I showed you before. Well, H2O is a compound. It's up here. What do we notice is similar about all of the symbols up on the periodic table? Most of them are 2 letters. They all start with what? A capital letter. And if they have a second letter, it's lowercase. And some of them are just a capital letter by itself. So, what is the correct chemical symbol for sodium? Why isn't it SO? Because it's the Latin name, right? And it's not just S for sodium, because S is for sulfur. Okay? And there isn't an SO.
Wait, are you gonna like give us like nitrogen and we have to like say like what it is, or do we get to pick one?
There will be examples given, but you're going to have a periodic table. Plus, there's 2 on the wall. So. All righty. Number 20. Oh, well, number 18 there says write the symbol for